Hello everyone. Today we're going to go over an example of how to run an Anova statistic in Excel. What you see in front of you is a fictitious data set that I put together. When I was looking around my office and I couldn't think of an example, I looked over and glanced at my Lego set. So what we're interested in is how long does it take in minutes to construct the Lego DB5 across groups of people with different levels of experience. So we have noobs that have no experience putting Lego sets together. We have the occasional ones that put together a Lego set every now and then. Then we have the master builders, which if you're familiar with the Lego movies, are great at constructing and do it all the time. Now some of you might wonder, well, what is a DB5? Well, I got that covered for you. It is the James Bond DB5 car here. The Aston Martin that they use. Has an ejector seat as well, and you can get an aftermarket LED light kit if you're that interested. I say that because I did purchase it. So with that, we're interested to see if there's a statistically significant difference in the time spent to complete the DB5 Lego set. To do that, you can see here we have three groups. So we know our independent variable is categorical, and our dependent variable is in minutes. It's a continuous measure. So with that, there's a few things that we can do ahead of time that when we run the Anova that we can get out of the way and then look at to compare. So here I'm going to put the sum, the mean, and the variance. Many of these we've gone over before. I'm going to go ahead and italicize these. So here, if we want to do sum, you can do equals sum, and you can just highlight the first one, pull it down. We luck out, there's 10. I made it that way on purpose. And we can copy this over so it does it for each one of these. For the mean, again, we can do the average. And we can highlight these, the 10 again, close the paren. We see here, copy that across. And not surprisingly, since there are only 10 in each category, if you take the sum, divide by 10, and that's what you're seeing here. So that should look familiar to some of you. And here, if we want the variance, again, it's the variance itself. You can double click the first number all the way to the last one. And now we have the variance for each one as well. I do this ahead of time, and I'm going to go ahead and put a bar down here just so we can see that there is a difference there. So I do this because when we run the Anova test, it's going to spit out and give us a lot of numbers to interpret. These will help us put them in place. So since we have the data here, we can go ahead and go into our data analysis. And here again, you have a number of different options to choose from. For this one, we want to use an Anova test, we know that. And with that, specifically, we want a single factor Anova. So if we click that, hit OK, it generates a table for us that we need to fill. So we're going to input our ranges. Again, going to highlight this with the labels at the top. Group by, here we have columns or specific groups. We have labels in the first row. The alphas here where you can change it to 0.05 is kind of the golden standard. You can change it to 0.01, 0.001. For now, we're going to leave it at 0.05. The output range, I want to leave it in the same worksheet so we can see where it's going. And I'm just going to put it to the right of the table. So now we see, and I can space some of this out, all of this pops up and we're wondering, how do I make sense of this? So let's start with the summary table at the top. And this should look familiar given what we did already over here. And let me just change that to where there's not as many decimal places. And we're good to go. So each one, so our groups here, noob, occasional, and our master builder, each one has 10, which lines up. Our sum, here again we see the same number, so that's where these are coming from. Our average, so we have our means of each group itself, and we also have the variance of each group. Here you can see there's a couple different rounding errors, so that's where you see, or rounding differences, not errors, that would align with these the same. So now you understand where these are coming from, and these are what are used, the means overall, the counts to calculate the sum of squares, the degrees of freedom, the mean of the squares, and then the F statistic, our p-value, and our critical value from the F table itself. We have our between groups and within groups. So if you remember from the formula, we need to know both of these to calculate the F statistic. So when you look at this table and we see between groups and we're looking at sum of squares between groups is all, so between each group itself. When we're looking at within groups, that's within each group the sum of squares. And then if you look at the bottom, these are truly the sum of squares total, so SST. Oftentimes, depending on what you're looking at, this could be SSB, SSW, so between and within. Now if we move over to our degrees of freedom, if we look at our groups, we have 3 groups, so it would be k minus 1, so we have 3 groups, minus 1 gives us 2, so in the F table we would go over to 2. And then within groups, our total sample size is 30 minus the number of groups or categories, so it would be 30 minus 3, which gives us 27. Total again is 29, but this would allow us in the F table to look up our critical value of 3.35. And if you look at the table here for Anova, if you take the sum of squares, divide by the degrees of freedom for each one between groups and within, we'll get our mean squares. So here it's 59,193, divide by 2, we get the 29,596, and then we also do the same for within groups. And now we have both the numerator and denominator. So if you take the numerator here between groups, divide by the denominator, we get our F statistic, our 35.943. Now if you're wondering, well, is that really it? You can always, since you're in Excel, do some basic math within to see if it is correct. So here we're going to take our numerator and we're just going to divide by our denominator. And you see here it does line up, it does give us the same answer here, so you know where that's coming from and why it's being calculated. You can already see that our F statistic, if we're comparing it to our critical value, we know that our F statistic obtained is greater than our critical value. What might confuse you here is our p-value has the E negative 0.08. So here that just is referring to the number of zeros that are actually present before the 2. So you'd have to move the decimal place over 8 spots, but there's another way. If you just change this, since it up here you see it's general, if you change it to number, you can increase it. You can see that it is significant. That's just another way of viewing it. If you see that E when you're running other formulas or examples or homework, you can change that to a number and it will change that format for you. So what you can see here now is there is a significant difference across groups. You don't know how they differ, you just know there is a difference. That's where you'd have to run individual t-tests between groups to see which ones are significant. But looking at it, we can reject the null hypothesis of equality, that all the means are equal to one another, and we find, based on our research hypothesis, that the means are not equal. So our F statistic obtained is greater than our critical value, so we know there's a statistically significant difference among our groups on the amount of time it takes to complete the DB5 Lego set. We don't know how they differ or what group differs from which one, but we know there is a difference. That's why Anova is almost a starting point to where you can run additional tests afterwards. We know there is a difference, we just don't know how they differ. So with that, if there's any questions, please feel free to reach out. Let me know if you have questions on this example or another one.